we are discussing trigonometry. Okay. See, in the last 2 days, the last 2 sessions, we discussed about some small areas of trigonometry. See, the first point is related to the introduction of trigonometry, and I mentioned you there the pre-requirements for the trigonometry as angle, and then the concept of similar triangles along with the concepts of coordinate system. These three are the basic pre-requirements for the trigonometry, right? And then see, we started with the angle. The second point is about the angle and its definition, right? And its measure. We discussed everything about that, right? And coming to the third one, it is about the British system. In yesterday's class, we discussed about the British system as well as about the French system. According to the British system, one complete revolution is divided into 360 parts and each part is named as 1 degree. And according to the French system, they divided one complete revolution into 400 parts and they named each part as 1 grade, right? So that's why, see, this British system is termed as degree system and this French system is termed as grade system. Now in today's discussion, I am going to deal with the Indian system, right? See, Indian system or circular measure or radian system, all are same actually, right? See, here the units for the angle is radians. That's why we are calling it as radian system. Since it is the ancient Indian methodology, we call it as Indian system. And everything, see, measuring of an angle is completely depending on the complete revolutions and on the circles. That's why we are calling it as circular measure, right? So as I mentioned you, in Indian system, the units for the angle is radians. So first of all, according to the Indian system, we need to define what is meant by 1 radian, right? Have a look at this. 1 radian, right? 1 radian is usually denoted by, as a notation, 1 with the small c there. As I mentioned you, in British system, to mention 1 degree, we can use a small circle, small 0 at the power. And in French system, to represent 1 grade, we can use small z at the power. Whereas in Indian system, to notate 1 radian, we can use a small c at the power, right? And I mentioned you here the definition, and I will explain the definition here, right? Look at the definition. 1 radian is the angle, right? Basically, all these are the measurements for the angles. So surely 1 radian is again an angle. Where the angle is located and what is the measure of that angle? See, according to the Indian system, first of all, we need to accept the definition of 1 radian, and then we can use the definition, we can develop the measurements for the angles. 1 radian is the angle made by an arc of length, right? Made by an arc of length equal to the radius at the center of the circle. Just think about it. I will give you explanation with a diagram. Okay? See, first of all, according to the Indian system, we need to know about the concept of 1 radian, and then we can extend it for different angles. See, for example, if you have a circle, look at this. If I have a circle like this, yeah, see, surely there is a center and there exists a radius for this circle. So if the center of the circle is some O and radius of the circle is some R, right? So I have a circle. Take any circle as you wish. No problem here. It is okay. Take any circle. You need to know about the center and radius of that particular circle, right? So I just drawn a circle on the board, and the center of the circle is O, whereas the radius of the circle is R. Now, what is meant by 1 radian? I think you know that. See, this boundary line is usually termed as the circumference of the circle. I think everybody knows it. And part of the circumference is usually termed as arc of the circle. Is it right? So what I am going to tell you is, see, if you take this is a circle, then this complete boundary is termed as the circumference. For suppose if I took part of this boundary like this is called as the arc of the circle. Now we need to consider an arc on this circle. The length of the arc should be equal to the radius of the circle. Right? Is it clear? Again, I am explaining for you. Look at this. I have a circle with center O and radius R. Since I have a circle with radius R, the circumference of the circle, the boundary line is of length 2 pi r. I think you know it, right? Since the boundary length is 2 pi r, on this boundary you need to identify a part of the boundary that we usually call it as the arc. The length of that arc, the length of the required segment of the boundary should be equal to the radius of the circle. First, suppose if I have an arc from here to here, right? See, if this length is again equal to the radius of the circle, you need to calculate the length of this arc as radius. If it is equal to the radius of the circle, then this arc, whose length is equal to the radius, makes certain angle at the center. Surely it makes certain angle at the center, right? This is radius, this is radius, this arc length is again radius. Such a diagram will make some angle at this center. Is it right? And that angle is nothing but 1 radian. You can look, see, just observe here. You take any circle with any radius as your wish. Some people may take a circle of radius 5 units. Some may take a circle of radius 100 units. And some may take a circle of radius 2000 units. No problem it is. See, take any circle with any radius. But to confirm the 1 radian, you need to concentrate on the arc length whose length is equal to the radius of that circle. See, I mentioned you different circles with different radii, and all of you, if you look at such a diagram and the central angle is same for everybody, that central angle is termed as 1 radian. Is it right? Once again I am telling you, 1 radian is the angle. Where we have that angle? That angle is at the center of circle, right? And how the angle formed? The angle is formed by an arc, and the length of the arc is equal to the radius of the circle. This is very clear actually, right? See, whereas coming to the British system and French system, they move with a different procedure. Initially, they divided the total circle into some equal parts, right? British system they divide into 360, French system they divide into 400, like that they did. But according to the Indian system, initially they made a definition for the 1 radian, and based on that definition, we need to calculate angles, right? See, for example, what is 1 radian? 1 radian is the angle made by an arc of length equal to the radius at the center of the circle, right? For example, I have a circle here. Look at this. Any circle, no problem, okay? Take a circle here, whose radius is, you may say, some r again. This is a circle with center at this point, and now I will take an arc on this circle, right? See, the length of this arc, if I say it has 2r, what I am going to tell you is the length of this arc is 2r. Then what is the angle made by the arc at this center? Okay, just think a while. What I told you is, if the length of the arc is r units, then the central angle is 1 radian. If the length of the arc is 2r, it double, no? Right? Then automatically the central angle is just 2 radians. What you say? Just have a look at this, right? Is it clear? So, for example, if this is r units, this is 1 radian. If I took another r units from here to here, again this is an arc whose length is r, it makes again an angle at the center, 1 radian. Now, if you took at the total arc length as 2r, then its central angle is 2 radians, no? Right? So, I will erase this for the space concern. You just look once again. We are discussing Indian system, circular measure, radian system, all are same, right? So, before going to discuss measure different angles in Indian system, initially we need to know about the definition of 1 radian. According to the Indian system, 1 radian is defined as the angle. Everything is angle actually, and that is the angle made by an arc of length equal to the radius at the center of the circle. To explain for you, I have a diagram here. I have a circle with radius r. First, suppose if you took an arc of length r, then this arc will make an angle at the center, and that angle measurement is termed as 1 radian, right? Actually, we don't have any measurement for the angle, right? At that position, we are going to learn the radian system. That is the actual concept, right? I have a protractor, I can measure. All these things are not there at the time where they define this 1 radian, okay? And what my second thing is, if the length of the arc is 2r, then the angle at the center is 2 radians. Is it very clear, right? So I will erase this for the space concern. So based on the length of the arc, you will get the angle at the center. So we need to make, yeah, see, length of the arc versus angle at the center. Length of the arc versus angle at the center. As per the definition, if the length of the arc is r, then angle at the center is 1 radian, right? If the length of the arc is 2r, then angle at the center is 2 radians. If the length of the arc is 3r, then angle at the center is 3 radians. Very clear, right? If the length of the arc is 2 pi r, right, just I am multiplying r with 2, r with 3, r with 2 pi now. If the length of the arc is 2 pi r, that 2 pi is a number like 2 and 3, is it right? So I am multiplying that r with 2 pi. The length of the arc is 2 pi r. Then what you say the angle at the center, then it is clearly 2 pi radians. Is it right? So if the length of the arc is 2 pi r, length of the arc 2 pi r means a complete rotation is over, right? Complete revolution, or you say complete rotation is completed, right? So according to the Indian system, one complete rotation revolution is represented as 2 pi radians. From there we have a chance to connect all the different systems, British, French and Indian, and then we can develop different conversions from one system to the other. Have a look at this. Once again I am repeating you, this is the initial definition. What is that? If the length of the arc is r, then angle at the center is 1 radian. This is the basic definition. With that basic definition, we extended everything. Look at this, right? Yeah, we have a chance to, if see, r 1 radian, everything we have a chance, and from there, if the length of the arc is 2 pi r, then the angle at the center is 2 pi radians, and from there we conclude that one complete revolution is equals to 2 pi radians, right? This is all about the fifth point of trigonometry. I will discuss all the concepts of trigonometry in point wise, right? For our convenience to discuss. If you have any doubts, to discuss with me at any time. See, if you noted everything in point wise, then it is comfortable to raise a doubt from your notebook or from our class. Is it right? So this is all about the fifth point. The fifth point is about the Indian system, radian system, 1 radian, and what you say about one complete rotation. This is all about the fifth point. Have a look and go for a screenshot. I will give you another idea related to this systems of angles. Yeah. What is the main difference between pi and pi radians? Think about it. Pi is just a number. Pi is just a number. Whereas pi radians is just like an angle. Is it right? So just like 3 and 3 kilometers. Is there any difference? 3 is a number. 3 kilometers is a distance. Just like the units of kilometer, here we have the units 1 radian. So basically there is a difference between pi and pi radians. You need to note it, okay? Pi is a number, and I think you know that the approximate value of that number is 3.14. It is the approximate value. Is it right? And whereas coming to here, pi radians means 3.14 radians. Already we have a definition related to the 1 radian. 1 radian, you know it, and it is 3.14 radians. Is it clear? So don't get confused with pi and pi radians. This is a number and this is an angle. Is it clear? And the next thing is the sixth point. The sixth point is about the British system, French system and Indian system all together. Right? See, for every system, basically measurement of angle is dependent on the complete rotation. Right? So one complete rotation or revolution is equals to 360 degrees in British system, and that is equals to 400 grades in French system, and that is equals to 2 pi radians. Is it clear? 360 degrees is equals to 400 grades is equals to 2 pi radians. Let us connect all these three things. 360 degrees, 400 grades, 2 pi radians. If you divide everything with by 2, then you will get that 180 degrees is equals to 200 grades is equals to pi radians. I told you pi radians is an angle and whose measurement is equals to the 180 degrees, right? and it is equals to the 200 degrees again. And again if you divide with 2, you will get that 90 degrees is equals to 100 grades is equals to pi by 2 radians, right? This is the initial idea, and by dividing with 2 we have all these things. If anybody asks you, see, what is the measurement of the angle in radian system which is equals to 90 degrees, then your answer is clearly pi by 2 radians, right? And again if you divide with some more, with another 2, 45 degrees is equals to 50 grades is equals to pi by 4 radians. Is it clear? And then if you wish to divide further more, you can do, right? See, so basically you need to memorize that one complete revolution is equals to 360 degrees is equals to 400 grades is equals to 2 pi radians. Or otherwise you can memorize this also, 180 degrees, 200 grades and pi radians, right? As I told you, since our country is ruled by the Britishers for a long time, we are using the degree system, and Indian system is our ancient system, so we need to learn something about the Indian system also. Basically in most of the cases in problems you will face the situations where there is a chance to convert from British system to the Indian to the British, but very rarely you can use that French system. So for some time leave that French system and concentrate on that British system to the Indian system. If you have that look now, see, 180 degrees is equals to pi radians. Since 180 degrees is equals to pi radians, what we need to say? We need to say 1 degree is equals to, this is 180 degrees, man, 180 times of 1 degree. Then what you say? 1 degree is equals to pi radians divided by 180, right? You may write it like this, pi by 180 radians also. Or otherwise from there 1 radian is equals to 180 by pi degrees. 180 by pi, as I told you, this pi is 3.14 approximately, right? And you are dividing this 180 by 3.14 approximately, then this 1 radian will become 57 point something degrees approximately. Okay, have a look at this. See, this is all about the 6th point where we are discussing the connection between the British system, French system and Indian system, right? These are the frequently used angles, and frequently we need to convert from one system to the other related to these angles. And now when you look at when you pay an attention on the British system along with the Indian system, 180 degrees is equals to pi radians here. From there 1 degree is pi by 180 radians, 1 radian is 57 point something degrees, right? Have a look at this. Okay, and if I arrange this, yeah. Now if you wish to convert some x degrees into radians, right, what you need to do? X degrees into radians, what you say your answer. In the same manner, for example, if you have y radians and you wish to convert that y radians into degrees, what you need to do? Just think about it. X degrees into radians, whereas y radians into degrees, what you say? That is very clear. See, very unitary method, everything is just unitary method here, right? See, 1 degree is what? Pi by 180 radians. 1 degree is pi by 180 radians, then x degrees is automatically x times the pi by 180 radians. So if you wish to convert a degree measurement into the radian measurement, you just multiply with pi by 180. Is it right? And whereas if you wish to convert a radian system into degree system, what you say? See, 1 radian is this 180 by pi degrees, then y radians is nothing but y times the 180 by pi radians. Is it clear? This is all about the 6th point where we are connecting all the 3 systems, and now basically we look at the connection between British system and the Indian system. So based on this we will face certain simple problems also, right? For example, yeah, what you say about 15 degrees, is it right? See, 15 degrees is equals to dash radians. See, with what number you need to fill in this blank. 15 degrees is what radians? To answer that question, you need to look at this. X degrees is equals to x times of pi by 180 radians. See, 15 degrees is equals to 15 times of pi by 180 radians. And on simplification, you will get it as pi by 12 radians, right? Likewise, we have a chance to convert from one system to the other also. Have a look at this. We need to compare 1 degree, 1 grade and 1 radian. Which is smaller and which is larger? That's what we need to discuss right now here. Okay, so I will mention like this. Look at this. We have this fundamental thing that one complete revolution is equals to 360 degrees is equals to 400 grades is equals to 2 pi radians, right? See, 360, 400, everything are numbers, right? This 2 pi radians also can be represented in number form, that 2 times of 3.14, which is nothing but 6.28 radians. Nothing wrong there. 2 pi radians is equals to 6.28 radians. Both are same, okay? And now our task is to compare these three. Look at this. See, one complete revolution is equals to 360 degrees. Right? One complete revolution is equals to 360 degrees. From this connection, if you think about 1 degree, what you say? This 1 degree is equals to 1 complete revolution by 360. The basic unitary method, nothing more than that here, right? And 1 complete revolution is equals to 400 grades. If 1 complete revolution is equals to 400 grades, then what you say about 1 grade? 1 grade is just 1 complete revolution divided by 400. See, you just leave the grade there and then send the number 400 this side. And now what you say about 1 radian? See, 1 complete revolution is 6.28 radians. But now what we need to note, we need to identify 1 radian. See, you just leave 1 radian there and drag the number this side, it becomes 1 complete revolution divided by 6.28. 1 complete revolution is a thing which is equal for all the three, and 1 degree is that complete revolution by 360, and 1 grade is that complete revolution by 400, whereas 1 radian is that complete revolution by 6.28. Now look at all these three. If you look at all these three, I think you know the basic comparison of fractions. Here the numerators are same. Since the numerators are same, the fraction having lesser denominator is automatically greater. Is it right? The fraction having lesser denominator is automatically greater. With that basic logic, see, if you observe the denominators, 6.28 is the smaller one. Automatically this fraction is greater. So 1 radian is larger among all the three. And then now coming to these two, here 360 is the smaller when compared with the 400. So this fraction is greater when compared with 1 grade. 1 radian is greater than 1 degree is greater than 1 grade. Among all the three, 1 grade is the smaller angle, 1 radian is the larger angle, and 1 degree is in between those two. Have a look at this. Very important one. Note this as your 7th point. Right? Okay. 7th point is all about comparison of 1 degree, 1 grade, and 1 radian. Have a look at this. And the next thing is, you will eighth point of trigonometry. Before entering into trigonometry, we need to learn all these points. Okay, we may discuss around about 10 to 15 points before entering into trigonometry. Okay, and the 8th point tells you about the relation between the length of the arc or the area of the sector when related to an angle. Right. So what I am going to tell you is, just look at this. I have a circle. This is all about the 8th point, right? With the center at O and radius is R, right? As we discussed, if radius is R and length of the arc is again R, if radius is R and length of the arc is again R, then this angle is termed as 1 radian. As we discussed, what we discussed? See, length of the arc along with the angle. We established the relation between the length of the arc and along with the angle. Is it right? So, if the length of the arc is R, then we say that the angle is 1 radian. And if the length of the arc is 2R, we say that the angle is 2 radians. See, and now what I am going to tell you is, from this, if the length of the arc is, some 1 unit, R means R units, right? If the length of the arc is 1 unit, then what you say? Your angle is 1 by r radians. Is it right? Is there anything wrong? Just look at this. For a length of r units, your angle is 1 radian. For a length of 2r units, your angle is 2 radians. If you multiply this length with any number, automatically you need to multiply that angle also. If you divide this number with any number, then automatically you need to divide that angle also. Basic unitary method. Here we are dividing this length with r. That means we are making this length of r with just 1 unit. Then the angle at the center is 1 by r radians. Is it okay? And now, if the length of the arc is some L units, then what you say? If the length of the arc is some L units, then angle at the center is L by r radians. We need to multiply both with L. Now, this situation where the length of the arc is L units and the angle at the center is L by r radians, that is described by this diagram. For example, I have a circle with center O. I will take an arc. I don't know its length. If you mark the length as some L, it is not dependent on L. See, dependent on R. Just you calculate its length using thread and scale. You note it as L. If the length of the arc is L, then angle at the center is some theta radians. Then look at this. I have this situation. If you mix these two, this diagram along with that unitary method, if the length of the arc is L units, then angle at the center is L by r radians. And here if the length of the arc is L units and angle at the center is theta, then if you conclude these two, you will get that L by r is equals to theta and L is equals to r theta. This is very frequently used formula related to the circles and angles and everything. L is equals to r theta. You need to know about each and every term of this basic formula. L is the length of the arc, r is the radius of the circle, theta is the angle made by that particular arc at the center. Once again I am repeating this. At the end, I will conclude it with L is equals to r theta. You need to note that this theta must be in terms of radians only. If the theta is in terms of degrees, then you need to utilize some other formula. This is something about the 8th point. Have a note, right? Go with a screenshot. See, look at the first situation. Angle at the center is theta radians and length of the arc is L. So, if angle at the center is theta radians and the length of the arc is L, as I mentioned with you, our relation is L is equals to r theta. So, you need to utilize this relation only if you know that angle is in terms of radians, right? And now look at this situation. R, L and x degrees is there. But to utilize this particular formula, you need to convert that angle into radians. Diagram, angle is equals to x radians, right? So, as per this rule, this length of the arc is equals to radius into its central angle. But the central angle should be in terms of radians, I told you. So, just convert the degrees into radians. We have a relation between the degrees and the radians. What is that relation? 360 degrees is equals to 2 pi radians. Then what you say about that? 1 degree is equals to 2 pi by 360 radians. And from there, x degrees is equals to x into 2 pi by 360 radians, right? This is all an angle in terms of radians. And now what you say about length of the arc? At the end, the length of the arc is nothing but L is equals to, right, r into the central angle. The central angle is this. You need to multiply with r. X into 2 pi by 360 into r. We can rewrite it like this. X by 360 into 2 pi r. Look at this. I think already you know about it in your mensuration part. In your mensuration chapter, I think you know the way to calculate length of the arc, where you can utilize this formula. X by 360 times of 2 pi r, the length of the arc, if the angle is in terms of degrees. If x is an angle in terms of degrees, you need to utilize this formula. If angle is in terms of radians like theta, you need to utilize this formula. Both are meant for calculating the length of the arc. Is it right? Both are meant for calculating the length of the arc. Okay? Right? If central angle is in radians, we move with the first one. If central angle is in terms of degrees, we move with the second one. This is all about the length of the arc. And in the ninth point itself, we need to note some more formulae related to the area of the sector. Is it right? I will give you there now. Just look at this. Yeah. See, for example, if we have a diagram, a circle, center, right, and a sector. See, note this length of the arc as L, and some central angle is located. This is radius, this is radius. See, certain area is located in between these two radii along with the arc length, right? That is mentioned as the area of the sector. Okay. See, at the center, surely you have some angle. Some angle. This is called as the central angle. So you need to know about the central angle. Okay. If the central angle is theta radians, you need to use few formulae. And if the central angle is some x degrees, you need to convert the degrees into radians and then you need to utilize the same formula. Here the first thing is L is equals to r theta. And here the first thing, length of the arc is equals to x by 360 times of 2 pi r. And the next thing is area of the sector. From the mensuration itself, we have a basic rule that area of this sector is equals to half LR. Note it down. If you don't know it, just try to develop this, okay? Or otherwise I will give you in some other time. Area of this sector, area of this region is nothing but half times the length of the arc 1 multiplied with the radius. This directly gives you formula to find the area of the sector. With that idea, here area of the sector is nothing but half L is r theta into r, and it is given as half r square theta. This is the area when central angle is theta radians. And now here, if the central angle is x degrees, then again you need to utilize this half LR. So you need to divide this with half and you need to multiply it with r. Then it becomes like x by 360 to get cancelled and you need to multiply with r. This is x by 360 times of pi r square. Have a look at this. The circle along with the radius and the central angle. If you face this type of diagram and the situation, you need to calculate the length of the arc along with the area of the sector. And to calculate the length of the arc as well as the area of the sector, you will have two formulas depending on the central angle. If the central angle is theta radians, you go with r theta. If the central angle is x degrees, you need to go with this x by 360 times of 2 pi r. If the central angle is theta radians, area is half r square theta. If the central angle is x degrees, area is x by 360 times of pi r square. Have a look at this. Go for a screenshot.